Have you ever wondered when we'll set foot on another planet? Or how likely it is that you'll live to see the day that a city is built on Mars? If you chose to do so, could you one day live on Mars? Well, the answer is more probable than you may think. Believe it or not, plans are now in place to take the first humans to Mars. Stay tuned. In the last 4 billion years, from the first single-celled organism to the sometimes intelligent human being, nothing or no one had ever left the planet. Trapped floating amongst the stars, humans fought wars and died for a land they could conquer, but never see in its entirety. That was, of course, until the Apollo missions of the late 1960s, when we finally left our tiny speck of dust and took our first footsteps towards the stars. Arguably, the Apollo missions stand even today as humanity's greatest technological achievement. Following victory in World War II, America became dragged into the Cold War with the Soviet Union. The war spanned decades, but was different to anything the world had ever seen before. Previous wars were fought with soldiers, and were often won by the side who could field the highest numbers on the battlefield. Technology developed during World War II, primarily the nuclear bomb, ensured that future battles between great nations would be a duel of science and engineering. The USA and the Soviet Union were entangled in a battle to appear superior over the other. In 1957, the Soviet Union launched the first satellite into orbit, called Sputnik 1. 4 years later, in 1961, the bar was raised when the Soviets successfully put the first man into orbit, Yuri Gagarin. This inspired America to set its sights on the next incredible feat, the moon, and America wasn't going to let this one go to the Soviets. NASA's Apollo program ran from 1961 to 1972, landing not 1, but 12 men on the moon during 6 successful missions. 1/5 of everyone on Earth, or 650 million people, tuned in to watch Neil Armstrong and Buzz Aldrin's first steps on the moon, inspiring a generation. A generation that must have thought that their grandchildren would be living on the moon. Fun facts. Did you know that Neil Armstrong claims he said, "That's one small step for a man, one giant leap for mankind"? It's one of the most misquoted lines of all time, with people believing he said the sentence without an A, creating a much more profound, "That's one small step for man, one giant leap for mankind." It's understandable though. It took 3 teams of audio scientists using spectrographs to highlight the A due to his thick accent. But they also weren't the first words said on the moon. That title goes to Buzz Aldrin, with the slightly less inspiring, "Okay, engines stop." Do you believe in fate? Because Buzz Aldrin might. Not only was he part of the first ever moon landing, but his mother's maiden name was Moon. Maybe the stars do align. During the Apollo missions, 2 photographs were taken that would inspire the masses back home: Earthrise and the Blue Marble. They represented the first time that humanity could look back at itself for what it is. Invisible, floating through space on our tiny island, and vulnerable. The photographs had profound effects and were primarily used during environmental campaigns. The missions inspired the world, triggering an upsurge in science graduates and hopefuls wishing to embark on new careers in the newly opened space industry. But unfortunately, that future never come to pass. Following the 6 successful moon landings, NASA slipped out of the headlines and funding began to drop. In the 5 decades that followed Apollo, man's missions to space were limited to Earth orbit, probes were sent to the solar system, and rovers to the surface of Mars. Although these are great achievements and the foundation of our current understanding of our local planets, they lack the bedazzle that the Apollo efforts had. Although investment dropped following Apollo, there were strong arguments to increase investment. The project as a whole cost a staggering $25.4 billion at the time. In today's money, When accounted for inflation, that's $158 billion. But despite this massive cost, it's estimated that for every dollar spent by the government on the project, $7 were returned to the American economy. In total, 1,800 products that we find around the world today were either created or first developed by NASA. Yeah, that's right, 1,800. Some of the most notable creations were wireless power tools, fireproof fabric used by fire departments around the world, modern heart monitors, CAT and MRI scans, and solar panel technology. Can you imagine how many lives have been saved by these products alone? And there's only 1,795 more. Anyway, we have had decades without inspirational space progress, until now. Space privatization, the endeavour of private companies attempting to operate in space, has been a slow grower. There have been hundreds of startups from the 90s that have pitched sci-fi sounding ideas, but getting the infrastructure in place to earn even a penny is almost impossible. But from the ashes of failure comes a glimmer of hope. I think we all know where this is going. Since being founded in 2002 by Tesla's Elon Musk, SpaceX has become the global leader in rocket manufacture and satellite distribution to Earth orbit. In May 2020, they become the first ever private company to send NASA astronauts to space. A bit like Uber, but with a rocket. There is, however, something I missed out. Along the way, SpaceX and Elon Musk began, just showing off. A major leap was made, a leap that could make space travel feasible. They developed the technology to land a rocket. This may sound small, but consider this. How much would your plane ticket to Hawaii cost if you had to build and crash the plane just before you arrived? And not only that, to get home, you would have to build, fly, and crash another. The ability to land the rocket slashes massive amounts of money from any future space ventures, meaning that in the future, even if investment in the space sector doesn't increase, which of course it will, more missions will be conducted with the current money pool. In 2021, $10 billion was invested into projects that focused on the moon or further, the highest ever in a single year. That year, SpaceX successfully put the first private crew in space. These were not astronauts, but normal people like you and me, the person that you stand behind whilst buying your groceries. So far, all of SpaceX's achievements have been made using its Falcon 9 rockets. There have been many iterations, sort of like an iPhone, but these rockets were only ever designed for orbital use near Earth. We were never going to find Spock with these. And so, a new generation is on the horizon. Yes, that's right, ladies and gentlemen. For the first time in human history, we have a roadmap, if not a little rough, to put humans on Mars. And not only that, but develop a colony on the Red Planet. A colony that would become self-sufficient, hopefully grow into 1 million people. And that's not just me dreaming, that's the actual plan. We're building a city on Mars. You might have guessed it, but advancement in rocket development plays a large part as to why it's happening now. SpaceX are working on their next generation of rockets, with a beast at its centerpiece, Starship. Testing is well underway on the super rocket, but it's a slow process. Every crease needs to be ironed out with years of testing in order to avoid disaster. So let me explain why Starship is so important. It's simple really, it's designed for outer space. There's also some clever technology that will debut with the Starship generation of rockets, most notably the ability to land on a pad that catches it with an arm, and orbital refueling. The refueling process will require Starship to blast off from Earth and dock with a refueling station, which will give it another dose of fuel. This additional fuel will allow the rocket to power its way further than any rocket before, with the record currently being the moon. It's not an outlandish idea. Craft have been docking with the International Space Station for decades. We just need to send substantial amounts of fuel to space ahead of time. better understand Starship, it makes sense to compare it to NASA's Saturn V, the oversized bullet that took the Apollo astronauts to the moon and the most powerful rocket launched to date. The Saturn V packed an impressive 7.5 million pounds of thrust, but Starship will more than double that power, with an ungodly 17 million pounds. And SpaceX achieved this at a fraction of the cost, with the rocket's development costing 5 to 10% of a Saturn V. When factoring the increased power, size in general, allowing the rocket to carry more and cost, you can see why Starship is a game changer. In February 2022, Elon Musk gave a press conference from Starbase, SpaceX's new launch center and production facility in Texas. It was here that Elon outlined the company's future for the Starship rocket system, ultimately ending with an objective of putting humankind on Mars around 2030. Obviously, this date could get pushed back. Life is not all smooth sailing, especially when you're sailing ballistic missiles. But the fact that 2030 is the objective is exciting. At worst, you could imagine the project being pushed back a couple of years by test failures, but any more would be unrealistic. SpaceX doesn't have to reinvent the wheel. All the technologies needed to successfully land and colonize Mars already exist. It's just a matter of confidence limits. If humans are going into outer space, everything must work. Every time, first time, or lives could be lost. SpaceX believe they can manufacture a rocket every month due to low production costs and upscaling. So that's the other angle. The plan is to build a couple of rockets at first, then reinvest in the profit made from contracting missions to build more rockets. And this is well underway. SpaceX recently won a $2.9 billion contract to take NASA astronauts back to the moon as part of NASA's Artemis project, beating Blue Origin, owned by Amazon's Jeff Bezos. Poor old Jeff was so bitter that SpaceX beat him to the contract. He offered NASA $2 billion as a bribe to reverse their decision. Thankfully, NASA held firm and rejected his brown envelope full of cash, probably worried that he'd rename the moon. Other plans are also in place to maximize Starship's potential. An important pillar is designing a new transport infrastructure. SpaceX has plans to send 1 million people to Mars, so we're going to need more than 2 or 3 launch pads. This isn't as easy as just building more, due to the power released during takeoff and environmental factors. A pad must be around 30 miles from populated areas. It's also important to be near the coast. If something goes wrong, and a rocket is going to tumble from the heavens, it's best to do so over the ocean. Jellyfish have remarkably soft heads. SpaceX are countering this by converting disused oil rigs into launch and landing pads. This would allow for pads that can be transported near any coastal city at a safe distance. They are also exploring the idea of using the rockets for point-to-point travel here on Earth. As the cost per launch is driven down over time by technological advancement or process refinement, it may be logical to launch rockets carrying cargo from one side of the world to the other. An aeroplane would take around 16 hours to take your cargo to the other side of the planet, yet Starship could make the same trip in 45 minutes. Starship could simply make more trips, carrying more than just a cargo plane. It's also important to talk about Starship's fuel. Traditionally, rockets are fired into space with hydrogen or kerosene, but Starship is powered by methane, a more cost-effective option. And just when you thought things couldn't get any better, for every ton of methane in the fuel tank, there are 3.5 tons of oxygen. Oxygen can be extracted from the air for just the cost of the electricity it takes to do so. As you can see, the rocket and its supporting systems are well under development. So let's look at the mission and its objective. Why should humans aim to colonize Mars? And even if we have a rocket to get us there, can we survive? Let's begin with the purpose of exploring Mars. Why should we go? It could be argued that we have enough problems right here on our doorstep. Any mission to Mars is expensive, especially one as bold as to colonize. Surely all that cash could better be spent ending poverty and fighting terminal illness here on Earth. Well, checkmate. Although, on its surface, the Mars mission may appear representative of Cold War demonstrations, there are some crucial reasons why having a colony far away from Earth, on another planet, could benefit all of us. As people, we like to think about the long line of generations that led us to where we are today. It makes us proud, provides us with identity, and provides a place for us in a confusing jigsaw puzzle that is life. They were then, you are now, and someone will be in the future. But what if there was a point where there was no future? An absolute point, where the last person has been born. Shouldn't we do everything in our power to ensure that never happens? Ensure that no event could ever endanger our species? The recent pandemic brought the world to a halt. A tragic event, but one that ripples throughout time. Plagues and pandemics have happened throughout history. There will unfortunately be more. For the last few decades, a pandemic reminiscent of the one we have just experienced has been top of the list as a threat to modern humanity when analysed by scientists and mathematicians. Yet, when the event transpired, we lacked significant infrastructure to respond to the situation. The world's governments did a fantastic job with supporting vaccine development and distribution, but they were largely working ad hoc, under a state of heavy stress. Global leaders didn't even know if we should wear face masks or not, or when a party is a party. In the future, probability suggests that humanity will face other challenges that could threaten our continuation. Just as viruses remain a constant, repeatable threat, a large asteroid strike is a potentially fatal blow. If you don't believe me, ask the dinosaurs. And whilst you're there, ask them if they'd have had a better chance if they were on 2 planets when that asteroid hit 65 million years ago. If dinosaurs can survive for over 100 million years, shouldn't mammals with brains as powerful as ours aim to survive longer? NASA's Jet Propulsion Laboratory and Planetary Defense Coordination Office track near-Earth objects that are in areas of space that Earth could move through on its orbit around the Sun. And in that space, there are 27,000 asteroids. Now most of these are small, around 10 feet in size. This is small enough to burn up as they enter Earth's atmosphere, but there are some giants. At a massive 25 miles long, although few and far between, the likelihood of colliding with one of these mammoth rocks is slim, but certainly isn't impossible. Nuclear war will also be a factor. Will we be intelligent enough to never hit the red button? Or will we have weapons in the future that are even worse? If we manage, against all odds, to survive the apocalyptic events that I just mentioned, we have one final hurdle. Our Sun, as you probably know, is a large burning ball of gas, a giant cluster of nuclear reactions. Although it appears eternal and endlessly locked in time, it does have a battery. Its fuel source, hydrogen. Unfortunately, for our long-distant future descendants, that hydrogen is not infinite. Once ran out, the Sun will begin to expand. Remember that point I mentioned earlier, when the last human on Earth would have been born? Well, this is it. All life on the planet will perish at this point. The entire planet burned to a crisp. The entire evidence of our existence destroyed. The climate crisis of today has taught us that despite scientific data, as a species, we sometimes invest in the present and not the future. But as individuals, we feel moral obligations to do our bit for future generations in our day-to-day activities. Shouldn't our philosophy also apply to issues that could destroy our species rather than the planet? Shouldn't we feel morally obliged to act? Although the Sun eating Earth sounds like the worst of all fates, the calendar is pretty much set on that one. We know when it will happen, and we have a deadline to ensure that we are off the planet. The other risks, however, nuclear war, a meteor strike, a super virus, they could happen anytime. Now, we have the technology to put our eggs in 2 baskets, a plan B in case the worst happens. It is the first time in 4.5 billion years that a life form could venture from one planet to another, with a hope to find a new home. Hopefully, we have a long time, a massive window in which we are lucky. We could have millions of years until we need a backup planet in a crisis, but we could have 50. I think it's fair to say that we must move to another planet at some point in the future. Why not now? We will still dedicate most of our resources to fighting our earthly-based agendas, but 1% on Mars would surely be a fine insurance policy. To put current interest and investment into perspective, NASA's entire annual budget is less than 0.1% of the USA's GDP. Now let's look at how a potential Mars colony might work. I'll let Musk sum this one up.
It's going to be cramped, dangerous, difficult, very hard work. You might die, and that's the sales pitch. I hope you like it.
A couple of decades ago, a colony would have been an unthinkable task. Years of having rovers on the Martian surface have allowed scientists to conduct extremely detailed experiments on its atmosphere, geography, and seasons. Coupled with its robot army, NASA's MRO, or Mars Reconnaissance Orbiter, has mapped out 99% of the planet's surface. But Mars is a hostile planet, with an average temperature of -60 degrees Celsius, and that can plummet to -120. You might want to take some thermals. The distance between Mars and Earth varies, but to take more cargo and use less fuel, you would assume that any launch will take place when the planets are at their closest point. At its closest, Mars is around 34 million miles away from Earth. To put that into context, if there was a motorway leading to Mars, and you could drive all the way there in a straight line at 60 miles per hour, it would take you over 76 years providing you didn't stop. In Starship, the trip is likely going to take around 5 months, but Earth and Mars don't align very often, so any trip, if you expected to return to Earth, would take a total of almost 3 years. When the first person sets foot on the surface, we will likely have sent all the resources required to survive ahead of time. First starting with a smaller base of astronauts, the settlement will grow, probably expanding in bursts as colonists and supplies arrive like clockwork every 2 years, dictated by the planetary alignment. The goal will be for the colony to become fully self-sustainable. If something terrible on Earth happens, the ships to Mars could stop coming. Everything will need to be made on Mars, from simple food to advanced computer chips. It is estimated that to build a colony the size of a city, it's going to take at least 1 million tons of equipment and material, which will need to be shipped to the surface over time. In addition, we'll need 1 million people. Again, theorists believe that it would take around 1 million people to ensure that every skill was covered to keep a city operating alone in space. Although this sounds like a massive number, it's only around 1/8 of the amount of people in London. And when another project, called Space One, attempted to take people to Mars, they had over 200,000 people declare interest. The first settlers will be astronauts. After that, it will likely switch to ticket-based, where you could buy yourself a seat to the Red Planet. You'll need a skill that they require, but SpaceX's objective is to match a ticket to Mars, price-wise, with the average cost of a home on Earth. At this point, there should be a steady stream of willing participants, with enough courage to make Mars their new home. That could be you. At this point, I'll be asking my family if they've ever wanted to jump 3 times higher. You are probably wondering how all this is going to be achieved. The first thing we are going to need is water. Thankfully, Mars has water in abundance. Billions of years ago, Mars had giant oceans and river systems like Earth today. Now, all the water is frozen in permafrost, covering the planet's surface. There are also vast quantities at the polar caps. Both the northern and southern poles of the planet are capped in ice miles deep. All we must do is design a machine that can heat the surface and extract the H2O into tanks. The difficult part will be finding a large volume of trapped water near the planet's equator. Any landing will need to make the most of solar power at equatorial regions. After that, we need air that we can breathe. NASA's Perseverance rover has been conducting an experiment on the planet's surface, pulling oxygen from the Mars atmosphere. The Mars atmosphere is primarily made of CO2. The rover is extracting the oxygen from the CO2 at 22 grams per hour. This is going to be scaled up for the Mars missions. A device is being developed that will run on an isotope thermometric generator, or a nuclear battery to you and me. The device is extracting 2 kilograms of oxygen per hour from the Martian atmosphere, enough to supply 60 people per unit. Once we are hydrated and not holding our breath, we may notice our stomachs start to rumble. We'll probably send years worth of food supplies to Mars before we get there, but to become self-sustaining, we'll have to master Martian agriculture. Martian soil is toxic, and outside of our protected habitats, radiation will drastically mutate biological matter. Instead, we'll have greenhouses with plants, fruit, and vegetables that can cope with low gravity conditions. We'll be selectively breeding crops that in later years will hopefully thrive. We'll have a head start thanks to years of research aboard the International Space Station in more extreme conditions. One thing we will need to make agriculture on a second planet feasible is nitrogen for crops. Thankfully, in 2015, another NASA rover heating rocks with a laser sniffed out nitric oxide. A major danger to humans on the surface will be radiation. The first settlers could utilize the planet's natural defenses such as caves. Wouldn't that be ironic? Humans starting life on a planet from a cave? Have you heard that one somewhere before? If we decide that a cave is too difficult for our delicate bodies and equipment, we'll ship ahead the first living habitats and build the rest once an infrastructure is in place. Some crazy ideas are being explored in relation to space homes of the future. Metals are the obvious answer, but resource and process intensive. We'll have to mine, refine, before manufacturing into the correct shape and eventual construction. Large-scale 3D printers could become an option, printing homes from concrete or ice. An interesting idea is currently being researched at NASA which involves fungi. Mycelium is the root structure of mushrooms. Surprisingly, it's an extraordinarily strong substance given its single-celled thickness. Layer upon layer, it could be grown into dense bricks. Scientists are attempting to program the mycelium to grow into pre-designated patterns, like 3D printing, but with a biological material. In large amounts, this mycelium would function as a great barrier against radiation and the planet's climate, making up the walls of Martian homes. One of the problems with sending rockets to Mars is that they are difficult to power. Unless we want a graveyard full of rockets on the Martian surface, we have to figure out a way to get them home. Thankfully, SpaceX has this one covered too. Due to Starship's new fuel systems that run on methane, we can collect naturally occurring methane from the surface, as well as from the human waste our populations provide. Methane has been found seasonally on the planet in the atmosphere, and has been imaged by satellite leaving caves in vast quantities. It has even made scientists wonder if simple life forms could be causing the seasonal plumes of gas. As you can see, plans are well underway to get humans to Mars in 2030. Maybe one day you could go, or your children or grandchildren could sit you down and break the news that they are going to help humanity take its next steps into the future. Thank you for watching. If you've enjoyed the video, please subscribe to the channel and don't miss the next one. Stay safe.